what's interesting about this is we have our recommended daily allowance of protein, and it is zero point 0.8 grams per kilogram. But that number is such bullshit.
What's that in
And
pounds?
so a kilogram is, so if you take kilograms multiplied by 2.2, then you'll get pounds. And so this zero point 0.8 came from these animal studies way back in the early 1900s, where essentially they were just trying to see, like, all right, how can we make sure our cows are not breaking down muscle? How can we make sure we get enough meat here? And they developed what are called nitrogen balance assessments. And what a nitrogen balance assessment is we talked about this in another podcast too, but you take in protein, and it's made up of a percentage of nitrogen. And it turns out protein is the only nitrogen source of fuel that you're taking in. You do get nitrogen from nucleic acids and such, but mostly it all comes from protein. So you can measure how much nitrogen someone's taking in and then how much they're getting rid of. Because when your body breaks down protein, that nitrogen component gets excreted mainly in the kidneys as urea. And so you can measure urea excretion and or nitrogen excretion in your urine and see how much protein people are peeing out versus how much they're taking in. If they're peeing out more than they're taking in, they're in what's called a negative nitrogen balance, meaning they're in this catabolic state. So they developed this for cows specifically to just determine, okay, how do we keep them in not a negative nitrogen balance, make sure they're getting enough protein intake to sustain lean body mass, because they don't want to lose money here. And so the nitrogen balance, it it's been around for so long. We've been using this. You basically measure nitrogen and then you multiply it by 6.25. That's all you do. And then it's assuming that protein has 16% nitrogen, which we know is not actually the case. And so it's not a very accurate measurement, and it it is been around for 75 years and we haven't changed it. And it's going to underestimate how much protein they actually need, because your body can get rid of nitrogen in other areas. You can poop it out. You can get rid of it as cells die, hair follicles and such. And so it's an underestimated value, first of all. And plus, it was studied in humans in a group of college age kids for like 7 days, and to get these values just to make sure, okay, how do you make sure you're not breaking down muscle tissue? So that's where the 0.8 grams comes from. But as it turns out, you need so much more protein than that. And the recommended amount for most adults seems to be this range, based on a group of meta-analyses, this range of 1.4 to 1.7 grams per kilogram. And if you're heavily involved in resistance training or extremely active, you're going to want to push that number up towards, 2 to even 2.4 grams per kilogram, which ends up being about a gram per pound. And the protein requirement is kind of sketchy to just think about it in that way, though, because when I say protein requirement, not all proteins are made equal. If I tell you need 1 gram per pound of protein and you take it all in a raw plant form, you're not getting even close to that, because plants are not, the protein within plants aren't very bioavailable within your body's not able to absorb them efficiently because they're tied up in all these fibrous components of the plants. They're there for the plant specifically. And so your body doesn't get all the amino acids within the plant itself. And not only that, but the amino acids within the plant don't contain what we actually need. So those essential amino acids, especially things like leucine and methionine, those things are suppressed. They're essential amino acids. We need them again for protein synthesis in our bodies. And so if I tell you to get a gram per pound, but you're taking in animal products, plant-based products, then you're going to actually need to increase that slightly. Because what's really important to focus on is we don't have just a demand for protein. We have a demand for the essential amino acids within protein.
So you're talking, with the plant protein, how much more are you talking? So you said 2.4 for animal, let's say on the high end, right?
Yep.
what would the number look like for plant?
So with plants, you're 70% of like raw plant-based protein is going to be absorbed. So you're probably going to want to increase that value by about, I mean, I would say probably about 10 to 20%, unless it's all straight raw, but most people don't just eat raw plants. You can, heat it up, cook it. It's going to break down those fibrous components. It's going to become more bioavailable. Or if you're supplementing with protein powder, if it's plant-based, is absorbed more readily than the plant itself. Still doesn't compare to like a whey protein. Whey protein has a 20% higher bioavailability than soy protein, for example.
Okay.
And so it's going to need to increase. I don't know the exact percentage here, but I would, because it totally depends on how you're taking in that protein.